Okay, audio looks good. Seems everything's working. So today, or tonight, what I'm going to be doing is we have a register page now here. I think I have to start it. All my stuff got shut off. So second, this. I have battery backups, the lithium iron phosphate backup with one of the solar inverters for power failure. And it works when I shut off the circuit breaker. It works perfectly fine, but I must have had a brownout or something today because it didn't work. My stuff all went out, but I didn't even notice a power failure or anything. So that's kind of annoying. I'm not sure what I'll do about that. No, pup, you don't need your toy right now. You don't need it right now. You're gonna destroy it. Anyway, so everything shut down, which is a bit of a problem. I would like that to not happen. The ideal is that, you know, until I have some real amount of users, I don't want to have to move my stuff to co-location. Co-location's expensive. I would say on the order of a few $100s a month. So that's fine if I have any amount of real users, but there's like some space between having, say, like, I don't know, tens or hundreds of concurrent users where like 0 to that amount. Like it takes a long time to get, say, tens to hundreds of concurrent users. And that's where I would consider it worth it to just buy some new servers, put them in a data center, start to add that capacity, and then not have to worry about some of these things. Although I'm pretty sure even in a data center, you're gonna have to deal with power failure issues, internet outages, stuff like that. So that's where you start to want to be in multiple data centers and stuff like that. But yeah, in the meantime, I mean, if I could just not have power failure as an issue, I have Starlink. Starlink going down is a problem that I can't do much about because I can't get a secondary line. Even if I could get a secondary line, it's unlikely. Like, I would be limited by whatever my weakest link is, so it wouldn't necessarily be worth it to have Starlink in something else because you would want to use your capacity. And Starlink's pretty low capacity, say like 200 megabits down and 20 or 30 upload. So yeah, but I need to not have these kind of outages. They don't take that long to recover from. If I have a brownout and I notice it, I can just go down and turn the servers back on. It should be less than 10-15 minutes. But like today, I didn't realize that was what was happening, and it took about an hour, and I don't have external alerts. That's what I have to set up at some point before I have real users, is external alerts that are completely separate from my infrastructure that just look at the website and make sure the website's up and running. That way I could at least be notified quickly. I can try to resolve it as quickly as possible. Overall, I think this happens like maybe once a year, maybe. So 10 minutes of outage at once a year is pretty acceptable. I'm much more likely to break my services more frequently than that. So the problem is you don't really want this kind of power failure scenario because it can create kind of a pain to deal with the database and stuff if it's got open locks, and how do you resolve that? Luckily my stuff shouldn't have locks for the most part, since we're just writing encrypted streams. And there's very little user data, so that shouldn't be a huge problem, but I'd like to avoid it if I can. So let's go ahead and start the servers. Start the server. There's two servers. There's the web app server, which is just Bytes, kind of front end server, and then there's the Elixir server. So if I start this, then it's going to have to compile the assets for the page. So yeah, this is the platform. If anyone hasn't seen it, anyone's watching, I'm sure if you're watching, you've probably seen it. You can see down here we have pings coming through. Kind of interesting to note that pings take 20-30 microseconds. This isn't including actually getting to the user and everything, so this is just kind of like within the process itself how long it takes to respond. So it was going to take longer than that, but yeah, things I think they can take around 100 microseconds. Like if it was, I wonder, it would be interesting to ping this on the same machine and just see like what the lowest possible amount you could get is. But machine to machine through the switch, you're talking closer to a few hundred microseconds at minimum. And for requests, you're talking closer to a couple milliseconds, like full HTTP requests. This is through WebSocket, an echo channel, a Phoenix echo channel. Or a Phoenix channel, sorry. Echo channel is what the name of the channel. So, we can create users now. One thing I did was like, you can use password manager. We have like a little help pages. At some point, I got to think about maybe separating this off as its own deployment, but right now this is the only page that exists. So it's fine, just kind of explains. But the fun thing here, let's say we do A, B, C, D, E, F, G, H. So we have 8 characters as the minimum. I looked at this quite a bit, and it's pretty frustrating. So the way this is all set up, you... My friend's saying it's a long time to... So the way this is set up is that your password is never sent to the server. That's actually how it set it up initially. It sent your password to the server. The challenge with that is if you send the password to the server, right, you have these encrypted streams you can read from, and your password is what you use to unlock your vault, and your vault has all your session tokens that give you access going forward to any messages. Then separately, I was going to have a different password or set up like a passphrase requirement or passkey requirement for restoring your history. Even if you can log into the account, like if someone took over your email, they wouldn't be able to see the entire history you had with all the groups. So the way it's set up, sort of access to the sessions and stuff, was that you would send over your password. Yeah. You would send over your password to the server. The server would hash it, and then give you access to I don't know. I'd have to think about it again. I don't want to think. I'll tell you how it's set up now. Basically, instead of sending your password, you create 2 hashes on the client of your password using Argon 2 ID, and then there's some parameters you can set. So this actually uses WASM. Out over here. If I went to crypto. So there's this hash WASM thing, which will let you do Argon 2 ID, and then you can choose how much memory you want to use and how many iterations you want to do. Argon 2 ID is a little bit harder to crack with GPUs and stuff because of this memory requirement. So you can't just stupidly parallelize it like you could with, say, bcrypt. Parallelize attempts. So yeah, anyway, basically on the client, on the client, you use Argon 2 ID in this WASM setup, hash your password. It takes a second or two. every single time you want to try to hash, you send up the hash to log in, and then you have a separate hash to access your vault. So when you log in, I think we verify you. We give you back a token, a cookie that has your user ID verified by the server or signed by the server. And so then when you make subsequent requests, you can now request your user vault using that session ID. And your user vault, you can use your other hash to encrypt or decrypt or write whatever you need to write to that user vault. So yeah, you basically have two passwords. One is to log you in, which then the server will let you access your vaults. And then the server doesn't know what's in your vaults, you use your second key. And both of those are just based on your one password. You get two keys. One verifies you as the user to the server, and then the server lets you access your vault. The server doesn't have to require access to the vault, but it's just like an extra level of security. So that's what we have now. Generating those two using the one hash as the password to log you in, and then passing your ID back down. What is going on? Oh, let's see what the... Oh, angry still selected. What the... Does it apply? So... What needs to happen now is that we also need to generate a passphrase that we use to also encrypt your user and session vaults. And we need to create the user and session vault. The user and session vault, so the user vault will have just kind of like basic user info that we might need to save. It won't change very often. The session vault will have all of your current leaf keys for all of the groups that you're in. And so if you get access to the session vault, then you have basically, and if you can keep getting access to the session vault, you can essentially permanently have access to the user's messages going forward. You still wouldn't have access to the history, but if you keep getting in, then you can save all the history. So yeah, it's kind of the basic idea. Start building out some of this. Here we have a stage 2, crypto foundations. Build the. This is what I need to read. I put this together, or Claude put this together after reviewing some plans and stuff. Account symmetric key, key wrapping, encrypted vault, recovery passphrase. So you'll have your password. And then you'll also have a passphrase that you can save to access your account, because we have no way to give you access back to your account because all of your stuff's encrypted. So in order to deal with that, you get a passphrase. If you forget your passphrase and the password, we can reset your account, so we can delete the user vault and session vault for the user, but we cannot do anything besides. We can just reset you, so you wouldn't have any groups anymore. You'd have to get re-invited to all your groups and stuff like that, which is not the end of the world. But we can't do any sort of email reset, but I think that's fair. The other thing too is if you have an open session, you can use that to log in again. So that's the other thing. 1 second. So for the password, I didn't want, what I was going to talk about when I started talking when I was thinking about this was, for the password, a lot of password stuff requires like a certain character or whatever. Stop that. And it just allows you to create pretty bad passwords. Like this has a hashtag and a number in it, and it's a bad password. So instead here we have something where you can do like bird, cat, dog, parrot. And so you can do just 4 words. You don't need any special characters or numbers or anything. You can do much more unique passwords. But the unfortunate thing though is that when you do passwords, cracking these passwords, like if this was ever lost in transit, stolen in transit, the hashed password, they could crack it fairly quickly. If you do, I'm basically requiring a year with today's technology, roughly, to be able to crack the password. That's not great, because potentially you can do this on multiple GPUs and stuff. Like, it would take less than a year in practice if they really wanted to crack it. So, you know, if you use a password manager, I didn't like this one. You'll get a password that's much stronger. That could even up the difficulty here. But this would prevent someone from being able to steal it, just using a password manager. Then your password manager itself needs a strong password, but at least you only need one to have access to everything. And there's like a little bit of a hoop someone would have to jump through. They'd have to get access to your password manager to be able to break the encryption. So the way Signal and WhatsApp do this is they use a PIN, and they just give you a maximum number of tries you can use to remember your password. This doesn't do that, right? So like if you want to try 100 times, you can do it. It's just going to take you a second or two per try to get your password back, because this is all local. So the server can limit how many times you attempt to log in some period. Yeah, but the server doesn't even really need to. What was I going to say? So the way Signal and WhatsApp deal with this is they just like use a short PIN and like a 5-digit PIN or something, whatever number digits. And when you try to log in more than 10 times, they just delete your vaults, essentially what are equivalent to your vaults. And so you have to start over. And so they use hardware keys, hardware security modules and stuff to do this, to hard limit the number of attempts. They can't be compromised, ideally, in theory. So that's better. My general feeling is I just wish I could force people to use passkeys. Passkeys are fine. Like, passkeys are more than most people need. They work fine. A passkey is essentially the equivalent of doing a really long password here, and then it's like stored in your iCloud keychain. So it's like using a password manager or something, but it's just you're getting a really strong password. It's very convenient to use because it's all tied to the hardware of your phone or your laptop, whatever you're using. So yeah, I wish I could force passkeys, but I was looking into it, and passkeys, so for passkeys I would need a hash for the password, and they just don't work well enough today. So anyways, I have to do this, and it's the best I'm gonna get for today. And if people use it, then I can change it later. Yeah, you can register, but I need to actually build out the features now. So the first part is getting the crypto stuff set up with the vaults for the user. Once I have the vaults for the user, I can start to make profiles. You can have an account, you can have a profile, you can search for other users. And then once I have that, I can start doing the stuff for the groups. So I can create group vaults. Each user will have their own group vault, which will have their historical keys to access historical messages. And then I can start saving every message historically encrypted on the server too. Yeah, that'll start to round out the feature set, the end-to-end encrypted feature, which will be pretty nice. So let's get started on this. Need this. So build the client-side cryptographic infrastructure, account symmetric key wrapping, encrypted vaults, recovery passphrase, and identity key pair. After this stage, user data is end-to-end encrypted at rest, and the server never sees private key material or vaults plain text. This is the thing, right? Any service you use that passes your password up to the server, which is most things, you're just trusting them, and you're trusting them not to have any what's the word? Leaks or anything like that. And it's just kind of a crazy amount of trust, right? Like, I don't even trust myself to do that because, you know, you hire people from all over the world. You have to trust that none of them are trying to compromise your servers, which is great because I just like know the interview processes, and like there's no check for that, right? There's no check to like make sure you're not working for another government or anything like that. So yeah, I mean, I couldn't even imagine hiring people and trying to guarantee that. And even if you didn't hire anyone, right? Like even if I literally only had 3 people I was working with and I fully trusted all of them, then we could still just make a mistake and someone could hack into our stuff and get access to things and log people's passwords and then be able to log in as them. So this setup is really nice because it just guarantees that can happen. This is essentially how LastPass and Bitwarden are set up. They don't actually pass your when you type in your vault password, they don't pass your vault password up to the server. Locally, you hash your vault password and then pass that up to the server. And it's very difficult to get from the hash to the password. You can guess. That's sort of the number of attempts that are needed and stuff. Let's see. So yeah, after this stage, the user data is end-to-end encrypted at rest, and the server never sees private key material. And then this is also just like a peace of mind thing, right? Like if you don't do it this way, which is how most things don't. I mean, most things work is not this way. You just always have to worry that you're compromised, and that you know someone has access to your servers, or whether that's a hacker or a government or an internal employee, who knows. So yeah, I've never seen anything like that in person, but I'm sure it must happen. So it depends on stage 1. Stage 1 is kind of the basic stuff we have set up already, which is just we generate the hash, we use that hash as the password, but we don't have any vaults or anything, so we need to start creating the vaults. The derived key function produces auth key and vault key. This stage puts the second half to use. Okay, let's see. Do you think our auth key and vault key names are appropriate? For the keys? The vault key is used for both the session vault and the user vaults. What? Ooh. Let's see. This stage puts the second half to use. Yeah, we don't use the vault key yet. What already exists? We have client-side Argon 2 ID versus via hash WASM.
It seems like you didn't provide any text for me to clean and convert for text-to-speech.
Why does that
Please
seem
provide
to
the
happen?
text you'd like me to work with, and I'll be happy to assist you.
1 minute. Auth key is fine. It's used for authentication. The name is accurate. Vault key is misleading. It doesn't encrypt any vaults. The actual chain is Argon 2 ID. So you generate 64-byte hash from your password, however long your password is. You get 64 bytes. You split that into an auth key and a password wrapping key. Password wrapping key wraps the account symmetric key. Let's see. The account symmetric key encrypts the session vault and account vault. Can't even. Let's see. Maybe I put it a little bit too loud now. The account symmetric key. The password wrapping key wraps the account symmetric key. The account symmetric key encrypts the session vault and account vault. So vault key is 2 levels removed from vault encryption. It's a key that wraps a key that encrypts vaults. The architecture doc calls it password wrapping key throughout, which is what it actually does. It wraps the account symmetric key and the password prefix distinguishes it from the recovery wrapping key. I'd rename it to password wrapping key. This makes the key hierarchy self-documenting. In the code, derived keys produces two things, one for auth, one for wrapping. The vault encryption happens elsewhere, so we do that wrapping on the server, or the user does that on the client. I don't think we want to do it on the server. All on the client, yeah. The server never sees the password wrapping key, the account symmetric tree, or any plain.
I explained that all cryptographic operations occur on the client, with the server never seeing the password wrapping key, the account symmetric key, or any vault plaintext, and that the client derives an authentication key and password wrapping key using ArgonTwid, generates a random account symmetric key, wraps it with AES-KW into a 40-byte blob, and sends it to the server as a base 64 string for storage. On login, the server returns the blob. The client read derives the password wrapping key, unwraps the blob with AES-KW to recover the account symmetric key, and then uses that key to decrypt the vaults.
Auth key plus. And how do we do the passphrase setup? Okay. Your favorite toy in the world. At registration, also all client side. Client picks 12 random words from the BIP39 word list. Client generates a random 32-byte recovery salt. Client derives a wrapping key, recovery wrapping key, mnemonic recovery salt. Client wraps the same account symmetric key with the recovery wrapping key. Client sends both blobs to the server. Gotcha. Thanks. Recovery salt. Okay. Go ahead and update. This all makes sense. So we have the auth key, the password wrapping key, I don't even know if password wrapping key makes the most sense. It's the vault password wrapping key. Actually, good result. What do you think? I'd keep it as password wrapping key. It's already precise. Password says where this key comes from. Wrapping key says what it does, wraps another key. Adding user vault would be inaccurate for the same reason vault key was. The key doesn't touch vaults. It wraps the account symmetric key, which encrypts vaults. The full naming chain is password wrapping key. Symmetric. Okay. I won't argue. This stage puts the second half. KDF parameters stored per user in the database, fetchable. I think we already have it. Rate limited, register and login mutations, timing attack. Loading dependencies, existing libraries are sufficient. Ecto absent. Crypto client side. Yeah, I think I'm gonna focus entirely on private groups. And once I'm like very happy with private groups,
I edited the auth context TypeScript file, replacing the set vault key call with set password wrapping key, and updating the provider value to use password wrapping key. I then ran a TypeScript type check and grepped the source tree to confirm no remaining vault key references, verifying the rename was completed across the relevant files.
once I'm very happy with private groups, then I think I might. But that'll take a very long time. The public groups almost work entirely differently than private groups because public groups need to not be end-to-end encrypted for the most part. #WASM, why web crypto only? All required primitives are available in web crypto API. No additional needed. Yeah, another thing is like, I'm doing this all for web right now. And web is kind of frustrating because you have to enter your password much more frequently because the session, like when you close the browser, is going to end. And we don't want to store your stuff in your application storage, I don't think. So it would be nice to build an app because the app can just save your credentials in a way that we can't really do on a website. But building an app's kind of... I'm gonna put that off for as long as I can until I'm like really ready to do it. I'm sure all this is working as a website. As long as I make consistent progress, it should be fine. Gotta do a little bit of work every day. Stay motivated. The type check error is pre-existing. Clean, no remaining vault key references. Derived keys returns auth key and password wrapping key. Okay. Together a plan to implement. One thing I've read about a lot of people who, yeah, this is like, I already have so much code. There's 50 files here. And I'd like to check it in now. But it really feels like these things are pretty linked. And I want to see it all together because some of this stuff right now is not correct. So if I check it in now, it's just going to change in the next commit. So I'd like to get the user vaults done, and that feels like a pretty good checkpoint where I need to review all of the code. I did take a look at a lot of this code. It all looks fine. There's like some little things you kind of like go back and forth with to make sure that they're reasonable. But yeah, for the most part, it did all this reasonably. Supposedly, Elixir, these kind of functional languages, the chat models are supposed to be a lot better at them. I think because they're simpler. I have no idea why. It's just, for whatever reason, they seem to do these better. And for everything I've seen from this code, I thought it was pretty good.
13 steps.
Reference design doc. I'm gonna let it go at this. We'll see where we're at. I'll start reading the key existing files to understand. Look at the notes now. The thing I've heard about code bases that have a lot of AI usage, like where someone's used AI to produce them, is that the individual decisions seem okay. like everything on its own seems okay, but there was just never like a high level person like thinking about what should be happening on a whole. And I do see that, like, even with the front end code, there's just a lot of times where it's like if the same person were making decisions, they would name stuff differently. They would have organized things similarly across the app. But with the AI stuff, like, it doesn't have a personality. Like, it doesn't have things that it prefers necessarily. And so it'll just do completely different things that you would expect from different people. And it makes the code base harder to understand. Maybe. I don't know. Maybe they'll fix that. How it feels right now. Okay, so it's going to migrate the database to add the crypto tables, which are going to store the encrypted blob for the user symmetric key in two different formats. One encrypted with the recovery phrase, and then the other one encrypted with the password hash. Create database migrations, create active schemas for wrapped key and user vaults. What about the session vault? Is the session vault part of this? Could be. Oh, stop destroying the toy. Our mission right now to get all of this stuff. And just mark the squeaker. Gonna have no more toy. Then there's gonna be no more toy. What did I want? I wanted to take it. Pop, bring it to me. Bring it to me. Hey, come on. Get a toy. That toy's gonna be dead today. Let's see. What about the session bolts? Yeah, the session bolts in here. Update accounts context. It's just so much code. This is why, like, you want to really know what you're doing beforehand, because then it just requires a lot less review, right? Because you already like went over it a bunch of times. Whereas here, like, if you don't make all the choices up front and really kind of think about the plan, then you're kind of retroactively looking at what it did and thinking, is this right? And then asking about it in the context of the code, and then rewriting the code takes a lot of work. So it really pays off so much to just spend more time planning. Because once you have a solid plan and know what it's supposed to look like, it's very clear where it did follow the plan correctly or where it didn't follow the plan correctly. And then if it didn't follow the plan, you can just say, you didn't follow the plan, and you can follow the plan. Much easier than trying to figure out what it did and why it doesn't make sense after the fact. Especially too when you ask it to migrate, like make a different decision that it maybe should have done in the first place. It'll miss places, so it won't update everything. It might miss some. It might not add all the tests it would have added in the first place. It might not remove all the stuff that could be removed. So definitely better to spend more time planning. Up. Oh, I forgot to doing because the webcam's is similar to a commonly used password. Yep, 39 word list. All 20. The entropy of 12 words from BIP 39 and 20 words from SLIP 39. I think 24 words has a higher entropy, but it's on BIP 80. BIP 39 versus alt. BIP 39 is the dominant standard for generating phrases. It's widely supported, but has some well-known drawbacks. Is the de facto standard. The 1048 word English word list is well curated. A checksum catches basic translation error. The optional phrase 25th word adds a layer of plausible deniability and security. BIP 39 criticisms. The checksum is weak. It only catches around 1 in 256 errors for the single word wrong can still pass validation. There's no error correction or detection of which word is wrong. The mnemonic to seed derivation EBK2 only 2048 rounds, which is considered low. The alternative SLIP 39 splits the seed into multiple shares using Schneer scheme 3 of 5. So no single backup is it. Uses a different word list. The trade-off is complexity. You need to manage multiple share cards and understand. Electrum uses its own mnemonic scheme that encodes version information directly into this. This means the wallet can detect which derivation path. Avoiding BIP 39's problem, where the same words can derive different wallets depending on the derivation. BIP 44, BIP 49, BIP 84. The downside is limited cross-wallet compatibility. Speed, Lightning Network. The BIP 39 has maximum capability. Single point. In practice, BIP 39 remains dominant because of network effects. Almost everything supports it. Most alternatives solve real problems, but at the cost of ecosystem compatibility. For choosing today BIP 39 with a strong passphrase and well-tested back strategy. One backup in one place. BIP 39 agent is still working. And passphrase 25th word. Your 24 word seed phrase derives a wallet, but BIP39 lets you add an extra passphrase on top. You use a different passphrase, you get a completely different wallet with different addresses. Why this enables plausible deniability. Say someone finds your 24 words, they enter their words and see a wallet. Maybe you've left a small amount of funds in it. Your real funds are in the wallet derived from those same 24 words plus a passphrase that only you know. There's no way to tell from the mnemonic alone that a passphrase protected wallet even exists. You can plausibly say that's all I have. The security benefit is simpler. Even if someone steals your written down passphrase, they can't access your funds without also knowing the passphrase. 25th word, which ideally you've memorized or stored separately. With the standard BIP39 setup, your seed phrase is one thing. Maybe written on a piece of paper or stamped on a metal plate. If someone steals that one thing, they have everything. If that one thing is destroyed in a fire, you've lost everything. That's a single point of failure. Flip39 and Codex 32 solve this with secret sharing. Your seed gets split into, say, 5 shares, and you need any 3 of them to reconstruct. You give one to a trusted family member, put one in a safe deposit box, keep one at home. A thief who steals one has nothing. If a house fire destroys one, you're fine. Okay. One backup in one place. So BIP39, you have to know the entire phrase. And you can't really split the phrase up. Can't you though? Couldn't you just store parts of the phrase? Hope it ran out of context, it's gonna have to come back. Couldn't you just store parts of the phrase? Let me see. Why couldn't you just store parts of the BIP? This is a really common idea, and it sort of works, but it gives you the worst trade-off in both directions compared to proper secret sharing. So you split your 24 word in 8 different words, you weaken security without eliminating risk. Each chunk reveals a portion of your seed. Any individual share reveals 0 mathematical secret. Pretty cool. Pretty cool. One thing that's so hard with this encryption stuff too is that the front end, it's very easy to tell if it's working, if it's correct or not. This stuff, it's like I have to actually look at it, the data, and see if it did it right, and see if everything looks reasonable, because there's nothing I can just look at, like there's no like website or something to tell like, oh, I did this specific thing. Here I have to actually just like look at all the code. Security form. I'll probably just try it though and see if I can log in. See if I have access to it. Test. Query vault. Type, ciphertext, not. Update vault. Query vault. Comes into play. I found the best way is to like review the code it gives me. It's like every time I see something I don't understand, I just ask it what it. Then I get a sense of like. Looks like it's working. Maybe not. Fix unwrap key. I don't know what error. The issue is the password. Key bytes correct. Function signature and colors. Gray buffer. I'll ask it what it's implemented. Where I'm at on use this week. %. Or halfway to Thursday. Oh, I can use it.
Permission requested. Command to reset test database with new migration.
Database up. Server, rather. One failure. Database busy as error. SQLite doesn't handle concurrent write tests. The issue is async true with SQLite. Any transaction based register user. Busy errors. Okay. Pass. Do we have? We should have tests on them. I don't think we have that set up. We don't have any tests set up right now.
SQLite concurrency failure by disabling async tests and verified that all 62 Elixir tests passed. I added new crypto migration scripts,
groups,
exoschemas, account functions, GraphQL types and resolvers, and client-side crypto utilities and UI components for registration, vault management, and recovery passphrase handling, and confirmed that lint, type check, compilation, and tests all succeed.
Take a look. Base. I think we need unit tests. Unit testing framework. Just some options. I'll have this other one give me some proposals for how we can do tests for the front end, and then I have that set up here and implement some front end tests. See what it says to do. Here's a summary of everything that was done. We added the identity key hash to users. Wrapped key. Oh, wrapped keys are the passphrase wrapped key and the password wrapped. So the user can request those, unwrap them, and then they can access their vaults. And we have user vaults. Do we have session vaults? Or just user vaults? GraphQL tests. I want to know more about this identity key hash.
It seems there is no text provided for me to clean and convert. Please provide the text you would like me to process. I will remove markdown formatting and code blocks, expand abbreviated units, and expand file extensions to full names.
On the client, session vault and account vault are types of encrypted in memory contents of Is it generally better to do a
I explained that the project currently has no test infrastructure and recommended adding Vitest with React testing library for unit and integration testing, and Playwright for browser end-to-end testing, outlining the hooks, utilities, contexts, components, and GraphQL operations to cover and the required dependencies. I proposed a directory layout that includes a Vitest, config TypeScript file, a Playwright, config TypeScript file, test folders under SRC for hooks, lib, context, and component tests, and an eTui folder with Playwright auth spec TypeScript, navigation spec TypeScript, responsive spec TypeScript, and theme spec TypeScript files. Would you like me to proceed with implementing both? There is no content provided to clean. Please provide the text you would like me to clean for text-to-speech.
Source. Test directories versus collated. What do I prefer? Both are
I
well
explained the
supported.
trade-offs between placing test TSX files next to their components and using a tests folder, outlining the advantages and disadvantages of each layout, and noted that both approaches are well supported by Vitist and work for the project, so you can choose the one that feels cleaner in your editor.
I kind of... Components already use a directory per component. I explained that co-located test TSX files suit a directory per component layout, showing how each hook or component can have its source, test, and barrel export together, and noted that the test's convention fits flat structures better. I contrasted the two approaches and asked if they want me to start implementing the Vitist and Playwright setup. This little setup test. Pup, stop taking all this stuff and out of that. Come on.
Permission requested. Command to verify Vitist runs successfully. Permission requested. Command to run Vitus tests in the Happy Groups web directory.
Validation contents, already unit tests for these.
Permission requested. Command to check playwright config load.
Yes.
Updated the EaseLint configuration JavaScript file to ignore eTWE directories and edited the gitignore to include playwright reports, test results, and coverage, then installed the new test dependencies. I added Vitus configuration TypeScript, test setup TypeScript, type declarations TypeScript, unit and smoke tests for validation constants and React rendering, created playwright configuration TypeScript and an eTWE smoke test, and updated the package JSON, Moon YAML, and test scripts. I ran the installations and tests, which all passed, verified playwright is installed, and noted that the WebKit browsers require a ~500 megabyte download. The remaining step is to run the playwright install command to download the browsers. I edited the playwright configuration TypeScript file to drop the WebKit project, leaving only desktop Chromium and mobile Chrome for local runs. I explained that WebKit dependencies are expected on a headless Linux server and should only be tested in CI using Playwright's Docker image, which includes all required system libraries.
How would you set up those integration tests in the How does it know what the page is? Unit
I
test
read
already
the
working.
CI/YAML workflow file located at home/JordanGarside/KiwiResearch/GitHub/workflows/sci YAML and reviewed its contents.
Is there a way to keep that part of the same job? I'd like avoid having multiple. Even if
I edited the CI/YAML workflow file, inserting a step that runs playwright install with dependencies to install the browsers and required system libraries, and I updated the moon run command to include the test-E2E task. I explained that the with_deps flag handles the missing GTK and GStreamer packages on the development machine and works on Ubuntu latest because the runner has passwordless sudo. I also noted that the filter option scopes the playwright install to the Happy Groups web project, so it doesn't affect other packages.
don't we need to?
I read the CI workflow YAML file and updated the playwright installation steps to separate getting the playwright version, ensuring that the large browser binaries and the dependencies installed with apt are cached. This change modifies the install playwright browser step in the GitHub/workflows/sci YAML file.
For this specific case, the single tables that are twice the vault is identical. Restored, sorry for no knowledge of what's inside separate tables, which same schema.
It seems there's no text provided for me to clean and convert. Please provide the text you'd like me to process.
GitHub Actions doesn't have a subjob concept. A job is one runner, one environment, steps run sequence. Here it's route server conf server.
I updated the Playwright TypeScript config to use a web server array that starts the Phoenix server and the Vite development server. And I modified the GitHub Actions YAML workflow to adjust the Elixir cache paths and the Playwright system depth step. I explained that GitHub Actions runs a single job with sequential steps, that Playwright will manage both servers' life cycles, and that the server uses SQLite permission requested exit plan mode.
Other guys besides, suppose we probably eventually set up thing programming our
explained the range of hosted SaaS, Kubernetes native, and hybrid CI/CD tools, highlighting that Argo Workflows is the natural fit for your Proxmox-based Kubernetes cluster, while BuildKite offers a middle ground with SaaS orchestration. I also suggested a migration path that keeps GitHub Actions for lightweight tasks and moves heavy builds, tests, and deployments to your own cluster.
Answers.
I explained how to install Argo workflows with a Helm chart via Pulumi, configure Argo events to listen for GitHub webhooks, create workflow template YAML files that replace the SCI, YAML, build custom container images containing Node, Elixir, and Playwright, and add custom code to report GitHub check statuses, outlining the relative complexity of each piece. I also noted that using BuildKite agents would avoid the need for Argo events, GitHub status integration, and custom toolchain images.
Separate components, I'll listen, forget. Yeah, so. GitHub status reporting. This part requires the most work. Argo doesn't natively support. You need either a small webhook in the workflow that calls the
Permission requested. Command to reset test database
But the
will split
report
vault tables.
success. Build kites. Three concurrent jobs per organization. Concurrent. Yes. Wouldn't use it. 50,000.
I edited the auth context TypeScript file to replace the old vault query with separate queries for session and account vaults. Updated task 5 to completed. Set task 6 to in progress, and then completed it after verifying there were no remaining references. Reset the test database, ran all 70 Elixir tests which all passed, performed TypeScript type checking and linting across the monorepo, and confirmed the Elixir code was properly formatted.
New review the code base. Updates. No, it's stage 2. See. That plan. Slide.
I changed to the Kiwi monorepo root at home/Jordan Garside/Kiwi Research/Kiwi.
Infra. And we go. Not planning to do CI AD right. I need tests. I can't keep going with it.
Permission requested. Exit plan mode.
So I want to do. Build product clusters operational, deploy Argo workflows, and to build prod. Argo events and CI workflow templates are out of scope. Build on top of this. This creation. Back repository configured. Kubernetes sequence FRW storage. Do we need to do anything? Naming wise? Argo workflows is a generic framework for constructing workflows. Argo CD focuses more on continuous delivery. We need to differentiate any naming at all if we would maybe want to deploy Argo CD. Argo CD. Eventually, although Argo CD probably wouldn't go cluster right. Comprehensive understanding. Good question. You're right that Argo CD wouldn't live in build prod. Naturally, the management prod are.
Permission requested. Exit plan mode.
Gonna be so many changes. Be miserable to commit everything. Where are the other? Flow. Document updates from the previous session are complete.
I updated the notes stage 2 crypto plan markdown to reflect the split vault architecture, revised schemas, GraphQL types, resolvers, client operations, and noted that all 70 tests are passing. I also revised the notes implementation stages markdown, marking stages 1 and 2 as implemented, and stages 3 through 5 as not started, while leaving the notes auth and E2E architecture markdown unchanged. No pending work remains from the previous session.
Written with stages 1, 2. Work.
I updated the task statuses, ran the TypeScript type checks, removed an unused destructuring line and its related import from the Argo Workflows index TypeScript file, ran the type check again, and confirmed it passed. Then marked the task as completed and reviewed the final state of the modified TypeScript files.
Then wrote it. I have a complete picture. So in theory, if I register, I should have session vaults, the user vault. I can access. How would I know? I have anything.
I edited the build cluster index TypeScript file to adjust the comment and modify the create Argo workflows resources call to reference the core prod stack output for S3 artifact storage credentials. And I updated the Argo workflows index TypeScript file to change the artifact repository properties from plain strings to Pulumi inputs. I then ran the TypeScript type check, which passed cleanly, and marked the related tasks as completed. I explained that after registration, the server creates a session vault row and an account vault row encrypted with AES-256 GCM, plus 2 wrapped keys rows, and that the client stores the user object, the raw AES-256 GCM account key, and decrypted session and account vaults in memory with needs unlock set to false. I described how components use the useauth hook to verify that the account key is present and unlocking is not required, and that settings page TypeScript JSX uses the account key to rewrap it when changing the password or regenerating the recovery key. I also noted that on a page refresh the JWT persists, but the crypto key and decrypted vaults are cleared, causing off-context TypeScript JSX to set needs unlock to true and require the user to re-enter their password to unlock the vaults.
Alright, here's how it works after registration. What gets created on this server? What are you doing, pup? What are you doing? What are you doing? Okay. Up. All right. After registration, you have both the session vault and the account vault, and the client has them decrypted in memory. Here's how it works after registration. A session vault row, encrypted blob containing identity, private key, an account vault, 2 wrapped key. But the client holds it. After register succeeds, these are all set. User ID, account key, session vault. How the client knows they're accessible. Any component calls use auth and key not equal to null. Vaults are decrypted. Raw crypto key. The account key is actively used in the settings page for change password rewraps the account key with the new password key. Regenerate recovery rewraps the account key with the vault contents are scaffolded for later stages. The identity private key in the session vault will be used for end-to-end encrypted messaging. The identity private key in the session vault the AWT survives storage with the crypto key and is there a reason we shouldn't? Save. Closing local store.
I explained that keeping the decrypted session vault in local storage is risky because any script on the origin can read it, exposing the identity private key to XSS attacks and leaving it persisted indefinitely on disk. So the safest default is to keep it only in memory. I suggested alternatives such as using IndexDB to store cryptokey objects, session storage for tab lifetime persistence, or encrypt then store where only a random session key remains in memory while the ciphertext is saved. I noted that this conservative approach matches patterns used by Bitwarden and Signal Desktop and can be revisited later with an opt-in stay unlocked feature.
Main concern is XSS. Local storage is readable by any JavaScript running on your origin. The session vault can private key leaks. An attacker can impersonate the user in your end. IndexDB can store crypto key objects directly via still accessible to XSS. Key isn't sitting as a plain string, and the attacker has to know to look for it and use System storage survives within the same tab, but clears on the vault content of random set for the site. Origin keep only the session. Current pattern require unlock on refresh is what Bitwarden is. Conservative choice and it's the right default. It's right. It's okay. Yeah, I don't know if that's reliable.
I explained that forcing password re-entry on every refresh harms user experience and doesn't provide real security because an XSS attacker can access any client-side storage.
Got on both points. Requiring
including
password re-entry and every refresh is a deal
I
breaker.
clarified that the only effective defense is preventing XSS through CSV, input sanitization, and avoiding unsafe HTML, and that the threat model should focus on XSS rather than re-authentication. I concluded that keeping users unlocked and storing keys in IndexDB or local storage is reasonable, and security effort should be spent on XSS mitigation.
and the crypto key and think index. We'd probably do index D if we're going this stuff. There's some library should be using index D because we're going to need to do where should be this entirely. We're going to need to fetch group data and give it structure for the app anyway. So might as well.
I confirmed that the build prod deployment succeeded, creating 7 resources and updating 2, and then I verified the Argo workflows pods, service, ingress route, HTTP route, network policy, and TLS certificate replica on the cluster, all of which were running and correctly configured.
Prod.
It seems there's no content provided. Please paste the text you'd like me to clean and convert for text to speech.
Another problem, the ingress route references service, the actual Helm created service. What full name? Big deal. It's the other link. Doing full name. So good question. There are 2 real options worth considering given that you need both crypto key storage and structured app. XCJS is the most practical. Minimalistic wrapper for IndexDB. IndexDB is a portable database for browser engine. XCJS makes it fun and easy to work with. Practical choice. There's crypto key objects natively. Version schema migrations. Groups and eventually encrypted message logs. X is the simpler path. You only want SQLite WASM if you expect any complex transaction. IndexDB's query model can express. What would be more performant? SQLite WASM or Index? Yep, no. Again.
I deployed the changes, verified that the service name is now Argo Workflows
Actually,
server,
a comment.
and confirmed the endpoints, and then grepped the repository for full name override and name override to see how other Helm-based resources handle the override. I also answered your question about the behavior of those resources. I explained that SQLite compiled to WebAssembly with the origin private file system gives synchronous file access from a web worker, delivering near native speed for bulk inserts, joins, and filtered reads in a single call, while using IndexDB as the backend adds WebAssembly overhead and
SQLite
asynchronous
WASM is faster for most workloads, but the storage backend is what
I
matters.
concluded that for a read-heavy messaging or social app with relational data, SQLite on the origin private file system is the more performant long-term foundation, despite the extra setup complexity and the need for a small IndexDB store for cryptokey objects, even though the WebAssembly binary introduces a startup latency of about 800 kilobytes to 1 megabyte.
SQLite WASM plus IndexDB backend. IndexDB, each operation is an async IPC encrypted storage engine. Simple key lookups are faster than anything that requires setting multiple objects. Means multiple async actions stitched together. It's expensive as data grows. The workload will be read heavy. Exactly where SQLite DOM. WASM binary adds. The data layer you're describing. Structure SQLite on OPFS. Origin private file system. We're first running the SQLite database engine within a browser using WASM for high performance. Trade-off is complexity. OPFS synchronous access requires running SQLite in a dedicated web worker. WASM binary startup latency, you still need a small. Could you go ahead? So should we set that up now or just store this? Need to store IndexDB. Which things versus SQLite?
I explained that we should use IndexDB for the crypto keys and decrypted vaults now and defer SQLite until we need it for larger app data like profiles or messaging. And I suggested creating a small IndexDB store using the raw API or a thin
IndexDB
wrapper
for the
like ID.
crypto now,
to hold
SQLite
the
later
count
when you
key,
actually need it for
session
the
vault,
app
and
data.
account vault keyed by user ID.
Cookies and
Want me to set
vaults
that
are small, so we'll store. Can we just set it up now if that's something we should do? It's not really over engineering because we're setting everything up. code. Hours. I could get CI moved over from GitHub Actions to Argo workflows and get some tests running. That'd be pretty good. Then tomorrow I'm gonna have to set up some more tests. Get this all tested. Tests are just so important with the LLMs. When they change stuff, they don't have any sense of like the rest of the code base. So it breaks stuff all the time once it gets bigger. Fair enough. I mean, still do. Concrete goals of this project include binding a low-level SQL 3 API closest to the C1 as feasible. Based API. Origin private file system. Augmented with a special surface.
Permission requested.
That brings
Fetch
very
web page
performant
about
access.
SQLite persistence on the web.
New surface differs from existing ones by offering OPFS Explorer. Sure. things like that. And hit my session limit. Minutes.
Permission requested. Exit plan mode. Permission requested. Command to cancel stuck Pulumi update.
View a SQLite provides a WASM build SQL synchronous sync of. Also provides a couple examples of various views. The higher ring persistent VFS. These VFS implementations are intended as examples rather than. Those 2022, SQLite has an official WASM build. Only a synchronous build is sync access handle. Actions can be opened concurrently, but only a single read or write transaction. This post intends to be shape the network tar pit automatically sync your backend data with SQL. Exactly what I mean. IndexDB or this company basically provides something provided, which was a thing called mini Mongo. Meteor.js had a mini Mongo library, so you could have Mongo.js on the front end. Let me actually see. Building groups app with posts, messages, etc. I need to structure clients. I know I can use IndexDB, but I think it won't. Hold on. So I think using SQLite WASM, something sense. This makes me think about mini Mongo. Meteor.js used to, still does. Mini Mongo must have been less performant. The WASM SQL item. The answer is nuanced, depends on the workload. Mini Mongo's performance. Mini Mongo is pure JavaScript in-memory implementation. Most queries are full collection scans. No real query planner. Once your data grows, SQLite crushes mini Mongo because it is a mature query planner efficient. Persistence, look at OPFS. The backend for SQLite is most widely deployed database globally. It is also becoming an option for data persistence applications. A couple of projects bringing SQLite to programs. SQL.js has been around since 2014. By itself, SQL.js only databases and does not instance. 2022, WA SQLite, implementing experimental support for existing SQLite data and IndexDB. Performance was quite slow. 2021, the absurd SQL project did the same, using a couple of new techniques to achieve much faster performance, even surpassing direct IndexDB performance. Company blog post has a lot of complexity. Well, it was a great showcase of what can be done. It was never maintained. The official SQLite project released their own data WASM build. None of these projects currently claims production level stability for persistence. We have found that the current support is already sufficient for use cases. Quarantine SQLite. SQLite supports concurrent access to a single database file by utilizing multiple functions. Currency should not be confused with thread safety. A single connection can be safe to use threads, but it serializes statements and can never execute more than one transaction. Execute multiple transactions concurrently, multiple connections. Each connection operates independently and uses a locking file system to protect this. copies from different threads or different processes. By default, SQLite uses a rollback journal against corruption. No read transaction can be performed while the write. Using the wall journal mode instead, the concurrency restrictions are relaxed somewhat. Read transactions can be executed concurrently with a write transaction with a single write. There's also an experimental wall 2 mode that allows multiple concurrent write transactions as long as they don't. Still experimental. Persistence on web. SQLite has a VFS interface. It can be used to implement a file system on any system. Generally, this implementation is run block data, read block. For the underlying story, there are two primary options.
I edited the base TypeScript and can you try loading https://argo build prod kiwi research net/ and see if the CSV errors are gone.
Down on my cut off. Want 95%, but yeah, 30 minutes. SQLite has a VFS interface. OPFS, this API gives random access to files private to the origin of the page. In principle, this API is ideal for database like SQLite, but the API currently you have some limitations covered in this. For general purpose database for browsers, there are options such as local storage are too restrictive. SQLite being a C-based library makes use of synchronizations. Still the case when compiling WASM.
I don't think so. No. Permission requested. Ask user for authentication approach for Argo.
We do a similar thing for check. SQLite C-based library, which means the VFS implementations of JavaScript must also be synchronous. The problem in the JavaScript world where file system. There's workaround. Asyncify translates the synchronous calls, allowing the VFS implementation. There are several downsides. The built WASM file size 2x. Performance can be reduced by 2 to 5. Behavior of SQLite may be affected by the transforms in Asyncify, and this build is not. Bugs in Asyncify cause subtle issues. SQLite team ADA heats here. The code requires running a group process. Additionally, significant overhead is added whenever used. So many things. JavaScript promise integration. The new WebAssembly ASPI functionality similar to Asyncify is a core browser feature. ASPI available in Chrome without a feature flag 2025 and as of October 20 support in Safari. There's indication the Safari team may add support in the future. File system API allows file system access using create sync access handle. These versions of Chrome. So there's some caveats. Operation on open file are synchronous. Opening a file is still an async. There is either pre-opening all files that could be used to combine or buffer. By default, opening a file takes log, meaning no other connection. Files are pre-opened and kept open for the duration of the connection based on a WG. A mode argument used read write unsafe writers. The read write unsafe mode is Chrome 121, but not Firefox. Okay. Concurrency for SQLite on I'm like a quarter of the way through this. Concurrency for SQLite on the web generally has the same restrictions as on other platforms. Each connection can be one transaction. Browsers do not provide support for multi-threading, including WASM. Multiple web workers.
Exit plan mode.
Cargo. Browsers do not provide direct support for multi-threading, including WASM, but multiple web workers can. Concurrent transactions may be supported over multiple tabs or within a tab. However, some VFS implementations require an exclusive lock on the data or having it time, in which case concurrent transactions are not supported at all. The single connection has to be shared between other VFS implement multiple. VSS multiple only a single. There's multiple read transactions is active. There is currently no implementation that supports read. For read transactions concurrently with write, while mode is required. Currently, there is no VFS implements wall mode directly. Would also not help because IndexDB, with the exception of read write unsafe mode available in Chrome, OPFS sync act, making concurrent read or write. OPFS asynchronous APIs have significantly worse performance and gaining the gains from. Since the read write unsafe mode became available in Chrome 121. This is such a good one. It's crazy, but I guess it helps them to some degree. A lot of information. Performance in SQLite is tightly related to file system. A couple ways to get better performance either. By default, SQLite assumes the sequence of writes to a file may be interrupted at any point in time. Rollback journal is used to allow recovery.
Removed the SSO hostname property from the Argo Workflows server definition in the base TypeScript configuration and the production TypeScript configuration, and I updated the build cluster index TypeScript file to adjust the dex credential comment and modify the create Argo Workflows resources call accordingly. Then I ran the TypeScript type checking across the monorepo, confirmed that it passed, and verified the final state of the modified files before marking the tasks as complete. I read the Pulumi
And I
wrapper
hit my
script
limit
at home
for 20
/Jordan
minutes.
Garside /Kiwi research /Kiwi / infra /K8 /script /Pulumi wrapper sh.
Annoying. I guess I'll deploy it myself. Do it myself. Cluster. SQLite can exploit this behavior. On the web, IndexDB can be used to provide the same guarantees, which then gives some nice performance improvements. Unfortunately, even though some of this in theory also provides similar concurrency wall modes, SQLite does not support that at the moment. This can be used, can be locked in exclusive mode. By default, SQLite only acknowledges a transaction, and it is safely persisted to the underlying storage. In other words, even an operating system crash will not lose the transaction. When using OPFS, files can be stored transparently, meaning the persistence format is exactly the same as what SQLite traditionally uses with no workarounds or additional metadata required. The advantage of interoperability between different implementations. It may be possible to switch out libraries completely without losing data already persisted. The implementations mentioned here are generally low level. SQLite APIs are exposed directly. A typical application would ideally use a library that manages transactions lacking web workers. And provides higher level APIs for querying persistence. PowerSync will provide wrapper libraries to support both Kaisley, type-safe query builder, and Drizzle, a more full-featured ORM on top of WA. Currently, this requires using the full PowerSync SDK. SQL local, run SQLite from your browser. SQL local makes it easy to run SQLite in your browser. It wraps a WebAssembly build with SQL. SQLite supports at-rest encryption using optional extensions. The commercial SQLite encryption extension supports building your SQLite WASM. Both options may require manually building the WASM builds. PowerSync includes a build with SQLite multiple ciphers, not designed for standalone use outside PowerSync. SQLite provides a WASM build with SQLite, both synchronous and asynchronous versions. It also provides a couple examples. Only the higher performing persistent BFS implementations are compared here. These BFS implementations are intended as examples rather than production-ready code. This version belongs to IndexDB. This files directly as file in OPFS. asynchronous open and read operations, and synchronous access handles for write operations. Need the asyncifier or JSPI build. Switch to a single transaction at a time. Be configured to support concurrent read transactions, however, there are potential issues. WA SQLite OPFS co-op sync. Concurrent sessions, file system transparency. Good general purpose VFS that has excellent performance even with large databases and works on recent versions of all major browsers. Increased performance makes up for the lack of concurrency support. Support for older browser versions required. I want to ask a question, but I'm out of tokens. What is the difference between using this and using WA SQLite direct? WA SQLite. All back to let's not have. We'll assume we can add a check telling the user their browser tool. I gotta ask you a question about this. When I get tokens back, I got 12 minutes. I'm gonna take a break.
नजरिया लागे नहीं कहीं ओ नजरिया लागे नहीं कहीं नजरिया नजरिया लागे नहीं कहीं लागे re no re na re na na re no re no dim dum da na da dim da na da dim dum da na da dim da na dim dum da na dim dum da na da dim da na o da ni da na di da na na o da ni da na di da na na da di ya na da dim dum da na da dim da na dim dum da na da dim da na dim dum da na da na dim da na da dim da na na da na dim da na da dim da na da na da di ya na da na na da na dim da na da dim da na na da na da di ya na da na na da dim da na na da na da di ya na da na dim dum da na da dim da na na dim dum da na dim dum da na da dim da na dim sa re ga ma ma ga re ga ma pa da ni sa ni da ni da da ni da sa ni da ni sa ni ga re sa ni re sa ni da ni sa ni da ma ma ga re sa ni re sa dim dum da na da dim dum da na dim dum da na dim dum da na na
local automatic web worker. distracted. Like busy errors in the middle of trans. We implement complex SQLite extension. To the one. So we gotta have it update this plan. Yeah, it wants to use this, which is fine. Doesn't really have a high level API. I gotta make sure this plan is decent before it gets started, otherwise things could become a mess. SQL local. So yeah, we won't use that. This power sync place basically provides their own SDK and framework for having a local SQLite sort of browser setup. And it would be pretty nice to use it because, yeah, you run into issues across different browsers. I'll have to just see how that works out. For the most part, I can do something that they don't have to deal with though, which is I can just require new browsers if you want to use the app. I can continue with this. New. To deploy build prod after this. Up, why are you licking your paw? You doing it?
Permission requested.
It's really nice
Exit
to have
plan
this
mode.
blog post though. Alright, what does it got here? Set up a 2-tier IndexDB, stores crypto key objects. Can't go in SQLite. SQLite WASM, structured app data. It says crypto key, so users they unlocked across page refreshes, SQLite infrastructure set up and ready for app data. Library choices, Kaisley, type city, SQL query builder, Kaisley dialect that handles worker creation. It's so clear that going forward, there's just going to be all these dependencies that the LLMs just pull in that are dangerous potentially. Let's see if this finished. Sulfur. For data in memory. Look at the rest of this plan. No IDB fallback, OPFS required, unsupported browsers, incognito Safari gets redirected. Reading app, secrets web. Order format, VS modules. Exclude WASM packages. Word chat. Hydration check browser supported, unsupported, and already on a help route. Raw index DB name. Public API re-export. Database module entry point new file. Public API re-export. Save keys from key store. Public API slash called barrel files. Take a look and make sure. At web. Up. Code split here. Right. SQLite database. Get the Kaisley instance. Your file. Changes this session. Keys found in IndexDB. Keys not found. After successful vault decryption, all saved keys to persist. Log out, but also here DB.
Permission requested. Exit plan mode.
Try this.
Permission requested. Command to install Kaisley and related dependencies. Permission requested. Command to fix formatting in key store, TS and migrations, TS files. I verified that the logout callers didn't need any changes. Ran TypeScript type checking and linting. Fixed prettier formatting in the key store TypeScript and migrations TypeScript files. And confirmed both checks now pass. I added new files for an async OPFS availability check, an IndexDB key store, a lazy initialized Kaisley database with migrations, and a static browser requirements page. And I updated the Vite configuration, client entry, roots, authentication context, and package JSON to integrate these features. All tasks are now marked completed.
Is helium support these features? With helium. OPFS. Test OPFS directly by calling
Permission requested. Ask user about the behavior they are seeing.
Almost certainly yes. Where's HTTPS? Returns false. It's from so I should reverse behind. How can I bind? We'll have an entry.
I examined the development configuration file and confirmed the regular expression for allowed origins matches http://localhost 5173. I inspected the router and endpoint modules to verify the core's plug is correctly integrated and saw that it is already present and configured properly. I explained that no further changes are needed for CORS support on localhost port 5173.
Nope. Here it is. Yelly.
I edited the TypeScript file to add enabled true to the SSO block, rolled back the failed Helm release, redeployed the build prod cluster with Pulumi, and then verified that the Argo server pod is running and that the SSO configuration appears in the config map. I explained that the Helm chart required the SSO settings under server SSO with the enabled flag, and after applying that fix, the deployment now works with DEX OIDC integration.
I could.
I changed the logout signature back to void in the auth context TypeScript file, then ran the type check and lint commands for the Happy Groups web app. I formatted the file with Prettier and ran lint again to confirm everything passes.
Right at JG42. Yep, that's taken. JG43. Looking. This use recovery. Also, it seems like the recovery passphrase modal doesn't use any of the line system. Let's see. Yeah. Need styling on. It also say that you can get this back in the setting. Now, we have our IndexDB.
I explained that the modal's font problem is unrelated to the database changes and is likely caused by the font family. Mono, setting in the Panda CSS configuration, not resolving to an actual loaded font, and I suggested verifying the font configuration or adding a proper monospace font.
We should probably add a this font. What do you think? Fonts. Let's see what's in here. Right. So we have a crypto key. This is what'll let us encrypt and decrypt our session vault and account vault. But we also keep them locally. Just wondering what keeps these in sync if they're refreshed. Are these pulled periodically? In theory, when you change it, you would update it on the server, but you'd have to make sure you never up.
I need some content to clean and convert for text-to-speech. Please provide the text you'd like me to process.
Like a speech. Fig tree and quick-train are both geometric with oriented friendly characters. Monospace font pairing should. Will fonts have? Mono, wow. 1900. We have JetBrains Mono, casual accent. Variable font with casual variant that has a bid. Then IBM Plex Mono. Cursive. Casual variant. IBM Plex. Oh wow. I don't like these B's. Okay, JetBrains mono. Oh yeah, it's funny. That was what it suggested first, and it's it itself. To those for better stuff. The other question I needed to ask was, I need to make it so that you can branch out of these so that I could continue with a context and like, because I wanted to do this, but I also wanted to do other stuff, and now I can't get back to that point, right? So Claude Web does. Claude continued to, yeah, I'm not gonna get out of Claude Code and then work the session. Oh, I guess you just open up a new /clone duplicate. It'd be interesting to. Let me see what happens if I do that here. That doesn't do anything. Lied to me. Google. You lied to me, Google. Cloning does not. Okay, so now I have different mono.
TypeScript file to add a mono font property and updated the Panda configuration to include the mono token. I confirmed that dev layout references the font URL and will pick up the change automatically. Then I ran the type check and lint commands to verify.
How does the
project
autocomplete
runs
thing
cleanly.
know that it should have done this, but the model itself doesn't know? Like, clearly they need. I need to know how these stay in sync. 'Cause it's kind of a problem if you do it right locally and it fails or something. It doesn't get updated. Can I see it again? Let's see. Did it actually add it in here? Request download. I don't think that's implemented. The thing that lets you see the passphrase again. Or reset the passphrase. Type
I
check
read
and
the
lint
button
both
TypeScript
pass.
JSX component and the card TypeScript JSX component to review their variant, full width, size, padding, and shadow props. I updated the recovery passphrase modal TypeScript JSX file to use those components and save the changes. I then ran the type check for the Happy Group's web application and executed the linting process to verify the refactor.
Do we have a way to view the passphrase again? Reset it. The modals dismiss the passphrase. I'm gonna passphrase reset. I just need to see modal again right now. Could you give me something I could type in my console? Oh. Never mind. It doesn't have it. Can you show me a dummy? With some dummy word values. Oh, that was not what I was thinking. And outside the box. So now I have we have those local entries will end for the user vault, session vault. How do we make sure? Like, do we write to them locally? Have something watches sync? Do we force the sync with the server for writing local updates? Do we pull the server periodically to make sure it's in sync? I'm not going to help with this. What? No. Freaking Claude. Claude, the police. He thinks I'm trying to fuck with someone. Do it myself. Maybe? Yeah. What we're actually seeking. The session vault contains identity, private key, affix states, changes when joining groups, rotating keys, contains device list, group membership metadata. These are encrypted blobs. The server stores as ciphertext only. Only the client can read or write the plaintext. Two tabs or two devices can modify the vault concurrently, and the server can't merge the encrypted contents. It just uses the opaque blobs. Server authoritative with optimistic logo writes. Fetch the latest vaults, decrypt them, and update IndexDB. On local mutation, encrypt the updated vault, write to IndexDB, and push to the server in the same operation. Server write is the commit. If it fails, roll back the local copy. Version counter. Add a version integer to each vault row on the server. Rewrite since version. Why not local first with that? All contains cryptographic. Not obvious. Conflict resolution on encrypted blobs requires decrypting, merging, and re-encrypting. We're going to need to do something similarly. For group content, right has to happen before you update your it. But let's say the user hits the old values. Yeah, then the would need. That would make me think that Phoenix channels would save us a lot. Because with Phoenix channels, we could more aggressively check to see if anything had changed. Like we could even just do some kind of quick hash on each item as it renders in the UI. Something like that. Check it against the server. Be right back. I have to wrap this up in a minute. Let's just try to clean all this up. Did this finish? We also kind of need a similar model for the group themselves, because I imagine let users update/delete messages. When you delete message signal, is it probably which means that you would need all item imagine you would want to the server every time. But yeah, I think we're going to I guess we could rely on pushes.
I examined the Argo server logs, tested connectivity from the Argo pod to the DEX OIDC discovery endpoint with wget and curl, and verified DEX was reachable. I inspected the server startup logs for SSO initialization, checked the OIDC client ID secret, and reviewed network policies to ensure no egress blocking. I concluded that DEX can be reached and the client ID matches, so the token not valid. Errors are likely due to a stale authentication cookie or another issue in the login flow rather than a connectivity problem.
the same. You're right. The polling is unavoidable for correctness. Push notifications are great for low latency updates, but they're lossy. Miss messages, reconnects, tab sleep, etc. You can't. Push for responsiveness, pull for correctness. External pushes tells the client. Periodic pull. Content hashing for polling. Item hash each message event. Keep to compute, store. No.
Permission requested. Command to template chart and find expected cluster roles. Permission requested. Command to find cluster role definitions. Permission
item
requested. Command to get server cluster role template. Permission requested. Command to retrieve all cluster role definitions from template. Permission requested. Command to get Argo Workflows controller cluster roles template.
Low. Descent into madness.
Permission requested. Command to get Argo Workflows controller CRB template.
Losing my mind.
Permission requested. Command to list all template sources. Permission requested. Command to list all cluster role and cluster role binding resources.
Okay, each message has a hash. Client sends group
Permission
ID
requested. Command to count all role and cluster role resources.
for everything currently visible. Server compares hashes, returns only items where the hash appears.
Permission requested. Command to list all cluster role and
Are
cluster role
you
binding
kidding
names
me?
from Argo Workflows template.
What are you doing? Okay, so the item ID. Skip per item hashes entirely and use group level version count. Each group has a
Permission
modifier.
requested. Command to check cluster roles in all namespaces.
Bumps on any. Group level version count, you'd have to fetch all of the stuff to know what it changed. Active view. Background groups. Use counter the group, then the user would have all. And there's just SSO mode, the server uses. Version catcher tells you whether something changed, not what changed. server tracks the version counter that increments on every station. The item would also store the version at which it was modified.
I ran multiple Helm template commands to list and count cluster role and cluster role binding resources. Discovered a chart bug where enabling single namespace creates namespace scoped roles, but the bindings still reference cluster roles. Edited the Argo workflows index TypeScript file to use cluster scoped RBAC for SSO mode. Deployed the build prod cluster stack with Pulumi for 10 minutes, and then verified that the necessary cluster roles now exist.
With the 64-bit integer, the max integer is 9 times 10. If a group had 1,000 writes per second nonstop, it would take 192 million years to overflow. Okay, so the version counter put only downside I gives us each client track. Gives you metadata on which item, what got updated. Trade-offs are so freaking. Thing I think about is like if you get subpoenaed and you're like, I mean, I don't know what groups this person belongs to. They could just ask for your entire database, like all of the groups. They wouldn't be able to do anything with it. But I think you basically just have to assume that your database is the government's property. Like, they're gonna have it no matter what. That's why I'm hesitant to any information whatsoever in it. Do you think what we decide? What we should? Do one foot in front of the other. Now, the vaults are a different problem. The version counter for this delta sync model is for for the polling or is there a big difference if we do that channels versus verification?
Permission requested. Command to list short status of specific files in the Kiwi Research directory. Permission requested. Command to show short status of Kiwi Research repository.
Phoenix channels, you already have the WebSocket open, pulling through the channel. Also, collapse the poll with push. Here's a push for a new message, and by the way, your version is now. It doesn't need to pull separately. It pulls an HTTP request. Headers, cores. That's means GraphQL endpoint is handling. The difference is small. Makes you wonder how the data go through channels. Maybe we can do. That would be.
Permission requested. Ask user question about CI trigger for Argo workflow.
The Argo events with the GitHub webhook requires GitHub to reach your IP. Huh. Argo events requires GitHub. They like that. Keep a minimal GitHub actions shot that uses. GraphQL over WebSockets is actually a well-established pattern. It's what GraphQL do. And increase mutation. I wonder if doing so it's we can't pull it. We do it. Also puts GraphQL via over WebSockets. Absence uses on Phoenix channel. Our adapter bridge the two.
Permission requested. Exit plan mode.
Keeper goal for queries mutation. Separate data pass circle handles the GraphQL. Your channel logic handle. So the Phoenix channels all need normalized data in I will.
I added a workflow template field to the Argo Workflows resources interface in the TypeScript file. created a workflow template custom resource named CI with repo URL and revision parameters, a single Ubuntu 22.04 container requesting 2 CPU and 4 GB RAM, a 15-minute timeout, an empty dir volume at workspace, and a CI script that installs dependencies and runs lint, typecheck, test, and end-to-end test steps, and then included this workflow template in the returned resources object. I ran the TypeScript type checking, which passed cleanly, and noted that the deployment can be performed with the Moon Kiwi Infra K8s, Pulumi command, and the template can be tested with an Argo submit command.
Feels like if WebSocket isn't fallback pulling in, then you would gotta call it. We'll deploy this. We'll see if it runs. Right, the WebSocket can drop for plenty of reasons. When it does, you need the data to keep flowing. Another argument for keeping the pull-based sync and treating Phoenix channel pushes optimization. Circle pulls every 15 to 30 seconds. The Phoenix channel is connected, push reduce. So then I have to always normalize and broken my channel pushes don't go through Urkel at all. Urkel handles cache. Its cache serves as an delivery. SQLite is the source of truth for message. UI reads. Try to normalize channel pushes. Fetches deltas via a GraphQL query, encrypts that, writes in this. Push the same thing. Decrypts, writes to SQL. Yeah. New document.
It seems there is no content provided. Please provide the text you would like me to clean for text-to-speech conversion.
Didn't make it as. Let me see.
I checked whether the notes directory existed, created the notes directory, and wrote a markdown file called client datasync, MD, containing design notes for the Happy Group's web client's data synchronization architecture.
Break it. For the group. Let's see that.
I edited the Argo Workflows Resources TypeScript file to add a Git credentials parameter, create a Git secret, include a Git token environment variable, and change the CI script from a template literal to a string array joined by newline. I also updated the cluster index TypeScript file to read the Git token from Pulumi configuration and pass it to the resource creator. I ran the TypeScript type checking command twice, confirmed it passed, and explained that the secret must be set with the moon command before deployment. It seems like you haven't provided any text for me to clean. Please provide the text you'd like me to process, and I'll be happy to assist you.
Oh. Like GitHub token. Let me do this right. Add git. They lay out the approaches, but the server already knows. In the architecture doc, the server already has per group monotonic sequence number dependent, message count, and total size. I turn the light off. Sleep. In the architecture doc, the server message count and total size, timing a very right. Which authenticated sessions fetch from.
I edited the Argo workflows TypeScript file to replace the get secret references with GitHub repo access secret, updated the comment and environment variable name to use github repo access token, and modified the build cluster TypeScript file to read the token as GitHub repo access token and rename the credentials.
I think we're gonna fetch from group
then
ID.
I ran the TypeScript type checking command.
I think that's gonna be public. Data is going to be public, so we don't. This is what the architecture already describes for you. Streams append only, the server assigns client ID last seek, server return. Edits and deletes are primitive. Edit entry references. Delete entry references. Press order and apply. Server learns from think. Which groups the client is reading? Server already knows that. Cursor position. Server. The model, nothing new. Take server. Edit. Maximally. State. Delete alteration. Pushable. Client must replay the full streamed. You are away and 500 messages sent. Only 2 were edits. 500 messages were edits. Coefficient has. Append-only strings. But approach 2, group version count with mutable items. Each group has a version count. Item stores the version modified. Edit slash deletes mutate items. Client send version. And deal with the other bugs. Each group has a version counter. Each item stores the version modified. Edit slash deletes. Version server. Returns items where plus the new. Server learns. Active group. Client's known version. Server learns data model total mutate. Goes beyond messaging. Reveals how many edits which specific items were server sees web mutation. Approach 1 editor messages for the server as items. Server can see when each item is last modified in object. Efficient delta sync. Which only changed. Efficient has anything changed. Here, one item. Server gains per item added. It knows item 47 was deleted at time T, even though mutable rows mean the server can observe edit. I don't know. Approach 3. Per item hot hash. Client sends those items in its view, server return. Client sends group ID. Server learns from sync exactly what item ID list reveals the correct content. Client sends hash. Only transfer items that hash list is built fingerprint. Cross size. I don't care about correlation. Yeah, like I worry about correlation, it's just I can do it. It's just hard. The thing I can do is I can make it public so that when you have to log into your user, you would know someone logged in on IP before they requested the group metadata. I don't like. It's not something I would store, but if someone logs in, you have a user logged in from some IP, and then data from whatever group access. You would basically have to be on the server to know that information, but sure. You still couldn't read any of the data. I think that's kind of like my guiding principle is like, you know, this is not going to be perfect because group stuff is very difficult. And have the experience be good, and it's not something I can do. If this was used by a lot of people, you know, you can slowly try to make it a little bit better. But my guiding principle is that it shouldn't be easy to do, and the what is said in the group. You know, if you share photos of your family or whatever, those aren't in some government database that anyone can see. And if you get hacked, servers were to get hacked by some malicious app, they would. Approach for opaque. Server issues an opaque after each sync. Server decodes the token. Server issues an Client sends it back. Client sends group ID sync token. Server returns change. Append-only stream plus lightweight. Keep the append-only stream. Add a lightweight group 6. Edits and delete. Group level count. Edits and delete. Level counter. Not exposing.
There is no content provided. Please provide the text you would like me to clean and convert for text to speech.
Please keep my hands on the extension. And I think something none of this really covers is that if you keep the original in the stream, even if you have the client locally delete it, and it's still accessible. Not really ideal. Password. Keep approach to document the metadata switch. Version counter plus tombstone model is pragmatic, efficient, good. Correction to the architecture. Let's delete 3 minutes. Sensible. Server also knows it is low sensitivity compared to protected. Move edits to leave. Version counter for set every row. Make cipher. edits our new rows. Guess if we do a there's nothing stopping us from deleting update the original message to basically the append only could represent placement of an old message. And only, I think. Your point on both public group data fetch
I explained
subscriptions
that
are
making group streams publicly readable removes the server's ability to link reads to specific authenticated users. And I described how append-only client semantics still allow the server to overwrite or tombstone original entries only if it knows a clear reference. I outlined 3 ways to handle edits: exposing the target sequence in plaintext, keeping the stream truly append-only and handling mutations client-side, or using an encrypted deterministic item identifier, and recommended the third approach as a balanced solution that lets the server perform replacements without revealing meaningful metadata.
client appends an or is it also tombstone theory? Server can't know which what's the target sequence? Data entry. Res there. Buy you anything. Whenever mutates old entry, the stream is truly append only and the client downloads both the original process and data version. The original ciphertext from the server went into remember who their epic client server. Client can specify. Item third option is probably the best fit. Server gets to perform the mutation. Can't make it submit. I imagine if you up that information. I think the practical choice.
I explained 3 ways to control who can edit stream entries. Adding a plaintext author pseudonym to each entry, using blind write tokens that the client must present to edit, and allowing any group member to overwrite entries while relying on client-side MLS signature verification. I concluded that the author pseudonym option is the most natural and clear despite a modest metadata cost, whereas the token approach is cumbersome, and the unrestricted method can cause disruptive noise.
Signal. My feeling is that we kind of pick rather than which means
It seems like you didn't provide any text for me to clean. Please paste the text you'd like me to convert for text-to-speech, and I'll be happy to assist you.
this coordination cover this. The doc specified message edits. I hold the credentials for message edits. You extend the same accent at right time. Private key verifies the math, authorizes the overwrite, and learns nothing. The messages, commitments, server avoids the trick. The cost is VLZK proof of PRF evaluation. A novel constructor, but it's harder to audit them. Also needs. Under second point, yeah. Wonder how Signal does. I think they just keep track of this message was edited, deleted. Or who wrote each message. IMI. iMessages. Under second point, yes, if you're mutating entries in place, the append-only stream is the alternative to avoid except that edit or the original. More sensible. New way for client. My feeling about it is you can't do the append-only because when someone's like going back through the history, You want to load those in order ideally. And you don't want to be doing some crazy thing where you're like having to load every single thing necessarily up front. Like ideally the client could even just pull in the latest stuff, and as they scroll up they pull in more of the group history. But it is kind of a problem to do like photos and stuff. You have to pull in the group history, but you could start showing stuff, you know, feed earlier. And so you'd just like be hopping things around, and things would be changing as opposed to just having chronological order with their exact states. You're mutating entries in place. The version counter follows net. Live stream or node that avoided the counter, but once you accept the edits, wait for clients to detect which entries have changed. The version counter is the minimal. How does Signal handle some deletes? I can't. I delete, so doesn't make decision how. I guess they don't store any history. The client maybe presents their sender key to the other members and says which message they want deleted. And the client expects that. The server sees the gap between entry. I have no idea how hard this is. Not ideal. Not ideal to have no idea how hard something is. This could be like extremely difficult. But what else do I gotta do? The model is fundamentally different because the server doesn't store history.
Messages only in a delivery queue and uses client-side sign delete or edit messages, allowing only the original sender to remove their own content, and why this approach cannot be directly applied to Happy Groups, because it stores a persistent server-side message stream. I also suggested that Happy Groups can still adopt Signal's client-side signature verification while letting the server perform authorized mutations to maintain security.
Yeah. Screen pulls history from the server stream, edits and deletes client to client instructions like Signal. I really got to think about this choice about whether to do append-only stream or to do updates to the stream with proofs. It's a lot harder. Append-only stream would basically mean that to load a group, you have to load the whole history first, which isn't terrible. Just imagine there's a group with like 100 gigs of data, right? You wouldn't be able to use the group until you downloaded all the data. Whereas if I can keep the stuff chronological, I could make it so you did me. That requires the. They're pretty big too. The dumb thing is, I mean, like the naive thing, and that's potentially like the better thing to the cost of liability. Do the last song. That works in principle. It's the append-only model from earlier. Deleted content persists on the server, so site protects indefinitely. Every new device replaces the full history. And has to process both the original and the deletion instructions to stitch them together. And will avoid it by not storing history. Signal avoids it by the fact that you can't fetch history retroactively. So like your canonical copy of your history is what's on your device, and that's it. Like it's just, we're gonna edit it in place in plain text. It's a pretty huge advantage. I might have to do it. The client itself can do whatever the fuck you want. That might just be too hard to do about that. I think that might be. I hate that, but I gotta think about it. It's painful. Think about it. It's a hard trade-off. The append-only model from earlier. Yep. This is the core tension, which brings you back to the server needing to authorize the mutation. ZK proof approach for that. You'll never need to solve this problem because its server never stores the data long enough to need to modify it. It's a pretty big advantage for Signal privacy-wise, like long-term, because the fact that I have to store the items, like even if I put them behind some strong encryption or whatever, it just creates targets. And you don't know, you just never know if there's backdoors to the encryption. The Signal doesn't really know what the messages are. It just knows who they're going to from. So, and it doesn't know who the people are that are behind to and from. So there's just less risk for the data long term, but I don't think you can do much about that. I think to some degree there's like a data snailness thing anyways, like I don't know if someone finds something out about you 20 years ago. Yeah, I don't know, it's still not ideal. Ideally the data would be like uncrackable for 100 years. Something like that. The client-side verification part still apply. Think about that tomorrow. This. Alright, I'm gonna end this stream. I gotta create this person token and try this. Probably do some more work with this tomorrow. So more Argo stuff and local DB vault testing. Alright, anyone watched? Thanks for watching. Catch you later.